Good morning to one and all present here. In the today's presentation, we are going to discuss about the transmission media, how it supports in the computer networks. So we know that we are having the 7 layers in the computer networks. It starts from the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. This transmission media comes under the physical layer, which will connect two different types of nodes from the two different end. So this is about the transmission media. We are going to discuss these things. The guided media overview of the presentation is about the guided media, how it is connected in the sense through the wire it is getting connected. Unguided media, through the wireless communication it is getting connected. Characteristics and the quality determined by the medium and the signal. For guided the media, for guided media, the medium is very important. As far as the unguided media is concerned, the bandwidth produced by the antenna is important. The key concerns of the communication or the transmission media is the data rate and its distance. The design factors of the transmission media is the bandwidth, transmission impairment, interfaces, and the number of receivers. Bandwidth is nothing but as much as the bandwidth is extended or the length or the higher the bandwidth is, the higher data rate will be. The transmission impairments are about the attenuations and the interferences, how it is disturbing the communications, and the number of receivers in the guided media and as well as in the unguided media. More receivers introduces the more attenuations as far as the multi-point connection is concerned. The guided transmission media, we are classifying the transmission media as three types. One is a twisted pair cable, coaxial cable, and fiber optics cable. So each and every types of cables are having its own features. It is having its bandwidth. It is having its transmission capacity. It is having its features and the characteristics and how it is supporting for the transmission media that we are going to discuss in the forthcoming slides. So this chart will give you the table will give you the clear information about the transmission characteristics of the guided media. Twisted pair cable, the frequency range is 0 to 3.5 kilohertz. The typical attenuation of the transmission media with the loading is 0.2 decibel per kilometer, and the delay is 50 microseconds per kilometer, and the repeater recommended for the twisted pair cable is 2 kilometer once. Twisted pair cable with the multi-pair cables is the frequency ranges comparing to the previous one, it is very less. It is 0 to 1, it is very high, 0 to 1 megahertz. The typical attenuation is 0.7 decibel per kilometer, and a typical delay is 5 microseconds. As far as the twisted pair cable with the loading is concerned, the delay comparingly very less, and repeater recommended is similarly same, 2 kilometers per one, and the coaxial cable is 0 to 500 megahertz of frequency range, and the attenuation is 7 dB, and the typical delay is 4 microseconds. Even though the attenuation is very high comparing to the twisted pair cable, the delay produced by the coaxial cable is very less, and followed by that the repeaters recommended for the coaxial cable is 1 to 9 per kilometer. Optical fiber cable is having the frequency range of 186 to 370 terahertz, and the attenuation is 0.5 to 0.5 decibel per kilometer, and the typical delay is 5 microseconds per kilometer, and the repeater spacing is 40 kilometer. So this is the diagrammatic representation of the twisted pair cable. Two cables are twisted together. Each and every individual cables are shielded, and it is bundled into the cables. Generally, we use this type of cables in the building constructions and all. And the twisted pair cable applications are, it is most common medium. It can be supported for the telephone network. It can be supported for the building constructions. It can be supported for the local area networks also. So as far as the local area network is concerned, it can transmit the amount 10 Mbps or 100 Mbps amount of data, depends upon the distance is getting increased, or the bandwidth is getting increased, the amount of data is getting increased. So the advantages and disadvantages of the twisted pair cable is, it is very cheap. It is not that much costly comparing to the coaxial cable and optical fiber cable. Cost wise it is cheaper, and it is easy to work, The data rate transmitted by the twisted pair cable is not similar, or it is not um, equal to the fiber optics cable or coaxial cable. It can send only low data rate, and it supports for the shorter range of communications. And the twisted pair cable transmission, the characteristics is it is analog signal, so amplifiers every 5 kilometer to 6 kilometer. Digital, use either analog or digital signals. Repeaters are recommended as we have mentioned in the table, like 2 kilometer or 3 kilometer. The distance is very limited, as well as the bandwidth is also very limited. Twisted pair cable is supporting for the low data rate. It means that maximum of 100 megahertz. It is susceptible to interference and noise. So coupling of signals from one pair to another pair are the crosstalks. Talks, coupling takes place when transmit signals entering the link coupled back to receiving pair. And shielded twisted pair cable. Unshielded twisted pair cable is an ordinary telephone wire. It is the cheapest one. It is very easy to install, and as well as it suffers from the external EMF interfaces. Shielded in the sense it is giving additional uh, field or additional safety for the cable. It is metal braid or sheeting that reduces the interferences. It is a little bit expensive or more expensive comparing to the unshielded twisted pair cable. It is harder to handle. It is thin and thick and heavy. So UTP unshielded twisted pair categories are category 3, category 4, category 5 and category 6 and category 7. Each and every categories are having its own features. It can transmit maximum of 16 megahertz and the wise grade founded in the most offices. And twisted pair cable length is 7.5 centimeter to 10 centimeter. And as far as the category 4 is concerned, it can transmit them 20 megahertz of data, and category 5 is up to 100 megahertz, and the 6 and 7 are having its additional features. Coaxial cable, so the next type of cable is called as a coaxial cable. The diagram itself clearly implies that it is having the inner conductor, and it is insulated by the insulation, insulated by the insulator, and it is having the outer conductor, as well as it is having the outer sheath, which is used to provide the security and safety that should not get disturbed or that should not get interfered by the external interferences. So comparing to the twisted pair cable, the coaxial cable is providing the maximum of distance. It can transmit maximum of distance, and as well as it can send the data with higher quality. Coaxial cable applications are, it is most versatile medium. It is mainly used for the television distributions, like aerial to TV and the cable TV and all. The long distance telephony transmissions, it can carry the 10,000 voice calls simultaneously, being replaced by the fiber optics. So shorter distance computer systems links local area networks it supports. So coaxial cable transmission characteristics are both analog and digital. In the analog, you have amplifiers every few kilometer. It is closer if a frequency is very high, up to 500 megahertz. Digital, repeater every 1 kilometer, closer for higher data rates. So optical fiber cable is the last cable. That is that the architecture itself clearly implies that it is having the light as a transmission signal. Light at less than critical range is observed in jacket. Followed by that, it is having the angle of incidence and the angle of reflections in order to provide the quality of the signal, as well as it is having the cladding, and it is having the jacket, and as well as it is having the core. In the core only we are having all the data transmissions and all. So it is a glass or plastic material that is coated for transmitting the signal, and a laser or light is emitting the diode for carrying the signal. Specially designed jacket and a small size, and it is weight. The benefits of the optical fiber cable are greater capacity. It can transmit maximum amount of data in the gigabits per second, smaller size and the weight, on the lower attenuations, electromagnetic isolation, and a greater repeater spacing, tens of kilometer at least. So fiber optic applications are long haul trunks, metropolitan trunks, rural exchange trunks, subscriber loops and LANs. Optical fiber transmission or characteristics are act as a waveguide for 10 to the power 14 to 10 to the power 15 hertz portions of infrared and visible spectrum. It is using the mechanism called light emitting diode. It is a cheaper, wider operating temporal range, lasts longer, injection laser diode, it is more efficient and greater data rate wavelength using the division multiplexing. And this is the three categories of optical fiber transmission: single index multimode, graded index multimode, and single mode transmissions. And the frequency utilization for fiber optics are wavelength is 820 to 900. The frequency range is 366 to 333. Don't have any band label. The fiber type is multimode. It is used for the local applications, local area network application. So when the wavelength is getting increased to 1280 to 1350, the frequency range is 234 to 222. The band label is called as yes. It is a single mode. It supports for various of applications. When it is supporting for having the frequency range of the wavelength of 1528 to 1561, the frequency range is the 196 to 192, and the band label is C. It is used under the fiber type of single mode, and it supports for wireless division multiplexing. Similarly, 15612 to 1620, the frequency range is 185 to 192. It is called as the band label as L. The fiber optics used is a single mode, and this also supports for the wireless division multiplexing. So the transmission frequencies are 2 GHz to 40 GHz. It uses the microwave, highly directional, point-to-point communications. It uses the satellite as a transmission medium. 30 MHz to 1 GHz. It uses the omnidirectional data transmission, and the broadcast radio 3 into 10 to the power 11 to 2 into 10 to the power 14, infrared and local. Antennas are used for wireless communications, or wireless transmission medium. So each and every antennas are having its own features and characteristics. About the antennas, we are going to discuss in the next presentation. Thank you for watching.